So for this question over here, you realize that 3y to the power of 4, first off, you know that this expression over here cannot be simplified unless you get rid of the brackets. So we agree that you need to get rid of the brackets over here. That's the first thing you would think to do. So if you realize it's going to be 3y to the power of 4, you know that 3y to the power of 4 is the same thing as 3 to the power of 4 and y to the power of 4. This is just from the basics of if you have a, b, c, just anything that's a product, and you do the whole thing to the power, as long as what's inside the bracket over here is a product, a, b, c is a product, right? A times b times c to the power of 3, it just means everything individually to the power of 3. This is just the rule you need to know about. So if you're confused about why 3y to the power of 4, if you did 3y to the power of 4, the reason why becomes 3 to the power of 4, y to the power of 4, and then consequently, if you do 3 to the power of 4 in the calculator, you go ahead and type that in the calculator, type in 3 to the power of 4, as in you understand how that simplifies into 81y to the power of 4, right? Yeah, it's just based off the principle that if you have a bracket of anything that's a product inside the power of a particular number, it's going to be everything individually. Okay, anything that's a product inside is individually to the power of that on the outside, multiplied together. So if you had, say, 2 times 3 times 7 to the power of 2, it's the same thing as 2 to the power of 2 times 3 to the power of 2 times 7 to the power of 2, whatever that is. So that's how we get the first part, 3y to the power of 4, which is going to be 81y to the power of 4, and then 3y to the power of negative 1. This is where you'd recognize the basic rule. If you have a fraction, so you look at this, you tell, okay, it's a fraction, but you realize a fraction is really just what? Top divided by bottom. If you have a fraction, top is numerator, bottom denominator, of course you know this, but you have to realize it's the same thing as top divided by the bottom. Meaning the rule is, what's really happening over here is the entirety of the top is divided by the bottom, the entirety of 81y to the power of 4 is divided by 3y to the power of negative 1, which you realize is the same thing as doing what? 81 over 3 multiplied by y to the power of 4 over y to the power of negative 1. You don't actually have to write it out this long way. This is just a method if you have to write it out. If you have to sort of work it out to be able to tell what the answer is, then you go ahead and do that. But otherwise, you'd realize very straightforward, right? It's just 81 divided by 3 because, you know, top and bottom, yeah? Top divided by bottom, top's of product, bottom's of product, 81 divided by 3, respectively, 27. Y to the power of 4 over y to the power of negative 1 is the same thing as what? Y to the power of 4 divided by y to the power of negative 1. Because see how this is going to be this multiplied by this? So the next part is really just, if you did y to the power of 4 divided by y to the power of negative 1, same thing as this, isn't it? Remember the basic rule? If you have the number on the bottom, if you have the letter on the bottom, the base is the same. These are both y's, aren't they? If the base is the same, if you're doing division, the indices, the powers just minus from each other. So 4 minus whatever negative 1 is, which is 4 plus 1, yeah? Because 4 minus negative 1 is going to be 5. And that's where you get 27y to the power of 5. And that's how you get this answer over here. Same principle over here, very similar, as in you recognize anything that's a cube root. Okay, there's a lot of ways you can go by doing this question. First way is, the quickest way really is, you realize the cube root of anything. Think about why the cube root of 27 is equal to 3. Think about why anything on your calculator, if you press equals, if you perform a particular function on the calculator, as in if you ask your calculator to do something for you, you're asking it to perform a function, right? The doi. The reason why it does that is it's supposed to give you something useful. It's supposed to perform a certain instruction that gives you something of use. My point is, if you type in the cube root of anything, if you type any number inside of here, the reason why that gives you, say if you had even 8 over here, and it's 2, like think about what it's really doing over here. What it's really doing is, it's telling you that 3 is the number that to the power of 3 will give you 27. The reason why if you did cube roots, as in cube root, if you type that function on the calculator and you type in 8 and you press equals, the reason why that gives you 2 is because by definition, 2 to the power of 3 gives you the number inside that function over there. Okay, so if you have this thing over here, do you understand it's the same principle over here? It's asking you to do the same thing, as in if you write inside of this function over here, the cube root function, ay to the power of 27, as in they're asking what this is. Do you agree that it's going to be whatever multiplied by itself 3 times over? Whatever multiplied, whatever to the power of 3 will give you 8y to the power of 27. So the quickest way to realize this is, well, what's the number that to the power of 3 will give you 8? The number that to the power of 3 gives you 8 is, what number is that? Isn't that 3? Isn't that 2? Yeah? So it's going to be 2, isn't it? And you think to yourself, what expression to the power of 3 will give you 27? This might take a little bit of mental gymnastics, but really it's, the reason why it's y to the power of 9 is because if you did y to the power of 9, think about this, look at the definition, if you did y to the power of 9 times y to the power of 9 times y to the power of 9, is that the same thing as y to the power of 9 to the power of 3 like that? And you agree that if you were to multiply all 3 of these together, it becomes 9 plus 9 plus 9, which is indeed 27. Now, if this method's not straightforward enough for you, you can just do it another way, which is the same thing as recognizing 8y to the power of 27 to the power of a third like this. Because do you agree anything cube root is the same thing to the power of a third? Try this on your calculator. Type in cube root of 27, press equals, of course you get 3. Now type in 27 to the power of a third, you also get 3. Type in 8 to the power of a third, you get 2. Yeah? So do you agree that anything cube root is the same thing as to the power of a third? As in, instead of doing something cube root like this, you recognize to the power of a third will give you the same answer. So if you did 8y to the power of 27 to the power of this, it's the same thing as this, right? Remember math, the rule over here, just in case, I don't think you'll be confused, but just in case you're confused, what are we allowed to do in math? You're only allowed to do whatever isn't actually changing what's being represented. As in, the reason why this is equal to this is because, well, this still represents the same instruction as this, because you recognize cube root is the same thing as the power of a third. Okay? And then you realize, remember from the basic rule, if you have a certain bracket and inside it's a product, is 8y to the power of 27 product? Is it the result of 8 times y to the power of 27? Of course it is. So that's where you can realize it's the same thing as what? Each individual component inside the power of a third. 8 to the power of a third times y to the power of 27 to the power of a third. How do you do y to the power of 27 to the power of a third? Remember the basic rule, if you have this expression, do you agree this is what's really happening over here? Y to the power of 27 to the power of a third? This is how you represent it? Yes or no? Do you remember the rule that it's going to be 27 times a third like this? As in, if you had a to the power of 2 to the power of 3, it's really the result of a to the power of 2 times 3. That's when you multiply. Whenever you have a certain power or something and you do it to another power with a bracket on the outside, you multiply those powers together. So if you have 27 multiplied by a third, of course it's going to give you y to the power of 9 like that. And that's where you get a to the power of a third, which is 2, y to the power of 27 to the power of a third, which is 9. And that's where you get the answer, 2y to the power of 9. This expression over here, this relies on the easiest way to go about doing this question. Make sure you have the best calculator money can buy, the FX991ES Plus, because if you type on this calculator, so this is me assuming that you remember from our classroom context how to use this calculator to do every single type of quadratic scenario ever in any exam situation. This is one of them. You can tell it's going to be a quadratic scenario, isn't it? Because, I mean, look at the dead giveaway over here. You have the AX, you have this question where it's what? They're telling you AX to the power of 2 plus BX plus C equals 0. You know where this is going. So if you look at this question over here, what's really happening is, do you remember the basics over here, just in case you forgot? Your calculator can solve for you quadratics, can't it? As in, if you gave to it, say for example, x squared minus 5x plus 6 equals to 0, if this is something you have to solve, your calculator can do that for you, right? Because you press modes, you press 5, you press 3, you press the A, B, and C, as in you recognize these are just the coefficients, the numbers in front over here. Press equals, and it'll give you respectively x equals to 2 and then x equals to 3. Why is this useful? Do you recall? You can use these answers from the calculator to factorize this if you really wanted to. If you wanted to factorize this expression, x squared minus 5x plus 6, you could factorize it by what? Because you have the 991ES, the best calculator money can buy, you can just write x minus 2 bracket x minus 3. Right, we're going to skip this. As in, do you recall that this is the factorization for this, of course, and you can actually very quickly find that factorization just by using the calculator to find what the x's are actually equal to, and then just rearranging them so that x minus 2 equals 0, x minus 3 equals to 0. That's what goes inside the brackets. So that's what's really happening over here, isn't it? As in, you recognize what? If you're provided with the actual x values that satisfy this. This question might be a little bit confusing, but do you recognize if they tell you these are the solutions, as in they're telling you when x is equal to this and when x is equal to this, you're going to satisfy this equation. That's what the definition of a solution is. A solution is what number you can replace a certain missing number for, a certain missing constant over here. They're telling you what these are numbers that can you replace the x with over here. As in, if you replace the x with negative 2/3, this whole thing will end up being 0. If you replace the x with 4, this whole thing will end up being 0. But the quickest way to do this is you recognize this is just what? If you were to use it to factorize in your calculator, it's going to be 3 multiplied to the other side, 3x equals to negative 2. Remember, this is the rule. It's kind of like, it's a machine-like process now, isn't it? You can just do it from autopilot. As in, you know this is what you get. And same thing over here, x minus 4 equals 0. Therefore, these are the two components that you multiply together in a factorization scenario. 3x plus 2, bracket x minus 4 equals to 0. See what we did over here? We turned this into this expression. This is what they really mean over here. And then if you were to expand this, check what happens when you expand this. Do you agree that this, like this leads to this? That's what you really have to comprehend over here. Like, if you don't understand how this leads to this, of course you're not going to be able to do the question. Okay? So as long as you understand that this leads to this, you'll be good. And then without further ado, it becomes 3x multiplied by the second bracket plus 2 multiplied by the second bracket. 3x squared minus 12x, 2 times x plus 2x times minus 4 minus 8 equals to 0. And that's where you get 3x squared minus 10x minus 8 equals to 0. Do we agree with that? And then, yeah, isn't that the answer? They're asking you to find the original equation, giving your answers in this form. Isn't this the original equation? Doesn't this fit the format? Ax squared plus bx plus c equals to 0? Self-explanatory. Number C, considering a quadratic equation. So have a look at this. Okay, let's look at this in depth. If you have x squared minus 3kx plus 2k squared equals 0. This question has a lot of ways you can go about it, but the way I recommend that's probably the most straightforward is, in order to show that one solution is twice the other solution, do you agree that the solution in this context, are we at least clear that solution is representing what the x value is? As in they're asking you what the x value is if you're talking about solution over here. Yes or no? Yeah? So if they want you to prove that one solution is twice the other solution, doesn't common sense tell us that we need to find what the actual solution is? That's the only way we can prove. That's the only way we can show that one is twice the other. As in the only way we can really do that is to find what they are. That's the easiest way to prove it, isn't it? The easiest way to show that one of the solutions is twice the other is to find what those actual solutions are, and then prove one exactly 2 multiplied by the other. Do you agree with that? As in, even if you didn't know how to do the math over here, even if you knew nothing about quadratics, you'd understand that in order to show that one solution is twice the other solution, it still involves finding the solutions. As in, if you found the solutions and proved that one of those solutions, one of those numbers, is exactly double the other, of course it's going to work. And then without further ado, you realize you think in real time. I'm explaining to you in real time how you would think to do this. You would think to do this because first off, you know what it's even asking you, you know what the task is, you need to find the solutions, and you recognize that this is not a quadratic equation. Yes or no? This might sound obvious as fuck, right? But they're telling you, if it's telling you a quadratic equation, what do you remember is the guaranteed way to solve a quadratic equation every single time. I mean, if you just want to sort of brute force it, it's a quadratic equation. Formula. It's the quadratic formula, isn't it? It's given to you in the formula sheets. In the end of your exam, in the real thing, they'll give you a piece of paper that literally tells you what the quadratic equation is. And you realize the quadratic equation, the little formula written to you on that document, you can just follow that document. Follow the formula they give to you. Remember the negative b plus or minus. Remember that formula? X equals to negative b. Does this ring a bell? B squared minus 4ac divided by 2a. As in, this is the quadratic formula that can be used to solve any quadratic scenario. Do we have a quadratic scenario? Of course we do. Do we know what the quadratic formula is? Of course we do. It's given to you in the exam in case you don't memorize it. And you realize the significance of this is what? This is the formula you can use to work out the x value every single time without fail. So we go ahead and do that. How do we do this? We have to write down what the a, b, and c values are, aren't they? A is equal to 1, b is equal to... b is not negative 3 over here. Make no mistake over here. b is not negative 3. b is what? Minus 3k. Okay? Make sure you're not confused by why the coefficient is minus 3k. If you're confused, ask me later, right? But yeah, just send a message if you're confused. But this should be pretty straightforward. C is going to be what? Plus 2k squared. Remember, you have to outline what the clear coefficients are before we substitute them in for the quadratic formula. Remember, stay on task, right? What are we doing this for? Like, why do we care? We care because this is the formula we can use to work out the x value every single time. If we worked out the x values over here using this formula, we found the solutions. If we found the solutions, all we have to do is just prove one exactly twice the other. So without further ado, we now go use the solution. Negative b, which is negative 3k. Yeah? So that's what's really happening over here, okay? This is, we found what the coefficients are when we substituted them in for the negative b plus or minus b squared minus 4ac equation. You can see what's happening over here. Do you agree? This is what it would look like, isn't it? If you were to substitute it into this quadratic formula. Negative b plus or minus b squared minus 4ac. Well, b squared is this, minus 4 times this is k squared. Divided by 2a, just like this. And that's where you get negative 3 plus or minus k divided by 2. And that's where you get 4k divided by 2, 2k divided by 2, just like that. And question, once you found this, do you need to be told that 4k divided by 2 is simplified into 2k? Do you need to be told to simplify it that way? As in, if you saw that from your working, you get 4k over 2, of course you don't need to be told that becomes 2k. And then the other one is what? 2k over 2, you don't need to be told that can be simplified into regular k. How is that not perfectly proving one is exactly what? The 2k is exactly double the other, isn't that what they're asking you over here? You've already shown it, didn't it? Have you not already shown that one of your solutions, because you have two solutions, you have this and you have this, isn't one exactly twice the other? K multiplied by 2 is 2k, right? Okay. It can't be any more detailed than that. Surely you understand this now. So quick recap in case, because remember you have to do this question beginning to end without looking at the solutions. That's the only way you move on if you really want to cram effectively, yeah? Quick recap from this question in real time. Here's how you would think about it to do it. It's like, you see a quadratic equation, okay, they tell you it's a quadratic equation, okay, la-di-da-da, show that one solution is twice the other. You know the guaranteed way that you can show it is to find the actual solution. You think to yourself, well, how do I find the solution of a quadratic? What's one way that works every single time? Oh, they're testing my knowledge. They're testing it. Do I understand that the quadratic formula will work every single time? So I go ahead and use the quadratic formula. I recognize the quadratic formula either from memory or from the formula sheets. I can just read it off, do basic substitution, and find my two answers over here, 4k over 2 and then 2k over 2, which are exactly what? K and 2k, which is the proof that one of them is twice the other. Okay. Part C. Now, when you look at the two curves over here, because you have the BIX, you have the, I believe, NCEA, this graphics calculator, you can just use the graphics calculator to plot these graphs if you really want to, and compare the visual differences. But there's an even easier way to go about doing this. At the end of the day, do you remember that? So look at this graph, x squared equals y squared plus 1. It might look strange to you, you might be familiar with it, it doesn't matter. You just realize this is one equation that has a certain shape, agreed? Every single equation can have a shape that you can plot on a graph. Yes or no? Do you agree that this other equation over here, y is equal to whatever this is, square, like bracket, just, you understand it's going to have a certain shape, okay? And when they're asking you for the points of intersection, this is just basic knowledge of it. Do you remember from IG? Do you remember from even year 10? How do you guaranteed find the intersection point of any two curves? The curves come from what? The curves come from the equations. As in, equation 1 over here represents a curve, equation 2 over here represents another curve. The guaranteed way is what? It's simultaneous equations. Does that ring a bell? Is it self-explanatory what we do when we talk about simultaneous equations? As in, we know where to go from there, right? Simultaneous equations speaks for itself. You rearrange for one of the letters, and you turn both of those into something involving only one letter. Because if you don't have one type of letter for an equation, you're not going to be able to solve for that what the missing letter is. Do you recall that principle of algebra over there? Just absolute basics of it. If you have an equation, it's just like if you have a, just in case you're confused, right? And a quick recap, if you have a plus b, let's just say a separate example, just to illustrate this concept over here. You understand if a plus b is equal to 10, you can't go anywhere with this. It's fucking useless. You can't get what a is equal to. You can't get b is equal to. You don't have that number. Like, there's not enough information over here to work out exactly what a and b is. But if you have a plus 2a is equal to 30, of course you can use basic algebra to work out that 3a is equal to 30 and then a is equal to 10. Why does that work? Well, why was that easy? Aside from the fact that you've done this a million number of times and whatnot, yeah? You do understand that this is easy because what? This is doable because what? There's only one type of letter in your overall equation. So do you see over here, simultaneous equations? It just means you have to change both of those. You have to combine this and this so that whatever you do at the end is going to be one equation with one type of letter. Easiest way to do this? Lots of ways you can go about it. First way is you could say that y is equal to, do you see this bracket over here? Do you agree that this can be simplified? Y is equal to bracket minus 2. Would you need to be told to simplify that? Of course not. Do you agree that's where you probably first look? There's a lot of ways you can go about this. I'm saying one of the easiest ways is you recognize the second equation over here. It's written in this bracket form. Do you really want that bracket form, or would you rather expand it and then simplify it so you have something easier to work with? Do you agree that what you get after expanding this bracket and simplifying is something that's preferable? You'd rather deal with that than whatever this is. Yes or no? Are you following this? Yeah? So if you don't need to be told to expand that and simplify, you'd realize you get y is equal to x squared minus 3. That's your second equation. You've changed that now. Okay? You can ignore it. And the first equation was x squared equals to y squared plus 1. And you can tell where we're going with this now, isn't it? A lot of ways you can go about doing this. One of the easiest ways is, can you sort of look at the bird's eye view? Look at this. There's so many ways you can go about this. You could, in theory, you could do y to the power 2 for the second equation over here. But if you did y to the power 2, you'd end up doing x squared minus 3 to the power 2. So you'd replace the y squared over here with this thing, which it's going to be doable, but is there something easier? Take a look at this, bird's eye view. Do we have the enough awareness to see that, look at the second equation over here. Do we have enough awareness to be able to tell that, oh shit, x squared is equal to this. Could we not get something involving x squared over here for y? Can we replace the x squared with something involving the letter y? Are we able to tell that y plus 3 is equal to x squared? Therefore, the x squared over here, if we just replace y plus 3, isn't that going to be much easier to deal with? Make the link over here. Pause the video if you have to. Okay? Just make sure you comprehend, as in, would you be able to spot, of the million different ways you can go about doing this question, to do the simultaneous? Do you agree that that's the easiest one? That's the most straightforward one, isn't it? You recognize if y is equal to x squared minus 3, you could find something that replaces the x squared over here to go over here. Yes or no? And then that's where you get y plus 3 is equal to y squared plus 1. Yes? And then you do y squared minus y minus 2 equals to 0. And then you've got the best calculator money can buy, so you can just type that in your calculator, can't you? You get the answer 2 and negative 1. 2 and negative 1. If y is equal to 2 and negative 1, let's write this down. Y is equal to 2 or y is equal to negative 1. Remember the easiest way you can interpret this to get the full answer? Because what are they asking? They're asking for the coordinates, right? This is where you go, when y is equal to 2, what is x going to be equal to? X is going to be equal to, well, what's the equation over here? They're telling you x squared is equal to y squared plus 1. X squared is equal to y squared plus 1. So doesn't that mean x squared? You have to plug it into that full equation to set it up to find what you need. This might be a little bit more complex than you're used to. You're used to just substituting the one letter into the other to get the other answer, right? But this one, there's going to be 2 more steps. My point is, if you know that y is equal to 2 and you need to find what the x value is to get a full coordinate, because every coordinate is x comma y, a number comma a number, you substitute what you know for a fact is correct. You know y is equal to 2, and of course it's valid. So you substitute 2 into this equation over here, because of course you use this one, isn't it? And you get x squared equals to 2 squared plus 1, which is 5. Which means x is equal to what? Square root of 5 or negative 5. Yeah? So easiest way you can do this, don't worry about this. This might be more confusing than it needs to be. You might have a hard time interpreting this. I'm telling you, okay, if you found that y is equal to 2, we already see how. Rewind the video if you have to, press J if you have to rewind to see how we got y is equal to 2 in case you've lost track. But assuming you're staying on track, right? You're aware how we got y is equal to 2 and how we got y is equal to 1, negative 1, excuse me. We're looking at when y is equal to 2, this is the best way to write it. You interpret this as when y is equal to 2, x is just going to be equal to what? Square root of 5 or negative 5. From substituting into this equation to work out for the x. So square root of 5 or negative square root of 5. And what do we really do with this? What we're really doing with this just means, square root of 5, because that's the x value, isn't it? X comes first. We can write this into a coordinate, can't we? Do you see how we basically got 2 coordinates? As in, when y is 2, we have 2 possible x values, which means what? It's just 2 coordinates, 2 points, where the y values are also 2. Just like this. And that's where we got our first answer, right? Next answer is when y is equal to negative 1. Just means what? X squared is equal to negative 1 squared plus 1, which is 2. So x is equal to square root of 2 or negative square root of 2, which means what? Y is equal to 1, comma, x must be equal to square root of 2 or negative square root of 2, which means it's just square root of 2, comma 1, and negative square root of 2, comma 1. If you're confused, leave a comment or send me a message. Just ask. But obviously the best way to do this is exactly what they've written over here, and then just write plus or minus for the abbreviation. This is just me explaining to you if you're confused about how the abbreviation here really works. If you don't really, if this doesn't really come natural to you, you can still just leave your answer as what? Square root of 5, comma 2, negative square root of 5, comma 2. Instead of writing it like this in the abbreviated version, if it's more intuitive to you, as in it makes more sense, then square root of 2, comma negative 1, negative square root of 2, comma negative 1. This question over here, I'm sure you recognize the only way this can be simplified. Look at the top. The top cannot be anything else other than potentially something factorized. So you can either tell straight away that it's factorizable, or you recognize you have to factorize it because that's the only way this thing can be simplified. Okay? X squared minus x minus 12. There's no other way you could write this unless it just so happened to be something you can simplify by factorization. As in you recognize the top thing over here can be written into a factorized format, as in a bracket times a bracket, and you're hoping that the top brackets over there, the top line, is 2 brackets that eventually cancel out with something on the bottom. And you see what's special about what's on the bottom over there. 4x plus 12. They clearly have what? 4 in common. So that's what you do over here, yes? That's why you would recognize, you factorize the bottom to become 4 bracket x plus 3. The top, in case you can't do it naturally, just type your calculator, best calculator you can buy, yet again. Find the x values and then use that to very simply factorize over here. Because if you typed in x squared minus x minus 12 on the calculator, 901 ES, you get x equals to 4, x equals to negative 3. Rearrange for those to get x minus 4, x plus 3 for the brackets. And you can tell straight away over here that these two cancel out, don't they? The x plus 3 cancels out with x plus 3. Remember when the top and bottom is both a product in math, you can always cancel out what they have in common, top and bottom. And that's where you get x minus 4 over 4. Simplest possible form, isn't it? Part B. Many ways to go about doing this, but the easiest way is, remember the basic rule about fractions, as in even if you didn't know how to do this question, even if you only had primary school knowledge over here, Asian primary school knowledge, by the way, not New Zealand, because they don't teach you anything in New Zealand yet, but do you remember? Assuming you went to private school in New Zealand, yes? You do remember the basic primary school algebra rule for fractions. As in if you have a fraction that you're adding together, if you have 2 fractions, you're adding them together or minus them. If the denominators are not the same, what must happen? Come on. Of course you know that you need to make the denominators the same, and what's the guaranteed way to make the denominators the same? You just multiply them together. And that's what we've really done over here. We've sort of taken that principle over here. We recognize, even though this is letters and numbers, it doesn't matter because it's still the same basic rule. If you're trying to simplify this, you're trying to combine 2 fractions. 2 fractions, denominators are different, therefore you must make the denominators the same. And we know the guaranteed way, right, is to make the denominators multiply together. X minus 3 multiplied by x plus 2. Remember the basic rule about if you multiply the bottom by anything, you must do the same to the top. So we multiply the top also by x plus 2. And that's how we got the same denominator over here. We can just write an overall longer line fraction, x minus 3 times x plus 2 on the bottom. Don't have to expand that just yet. Top is going to be 5x because we multiplied x minus 3 with x plus 2. That's why we multiply 5x by x plus 2 also. And this is what this expression represents. Minus x plus 2 multiplied with what? X minus 3. On the bottom over here, same thing, isn't it? Yeah, as in, you know, x minus 3 times x plus 2 is the same thing as x plus 2 times x minus 3. That's why we've written just this expression to represent both of those denominators. We combine them. The top is just going to be what was x plus 2 multiplied with? X minus 3. So we must do the same to the top of x minus 4. That explains this product over here. And then without further ado, you wouldn't need to be told what. The top can be simplified, can't it? You're not going to leave these all in that form. Of course not. So you go ahead and multiply them together, expand them out, simplify them, and that's where you're going to get 4x squared plus 17x minus 12. You're definitely going to get that. Divided by the bottom expression over there, which can't be simplified any further. You could potentially just multiply the bottom brackets together and then simplify, but this is already the simplest possible form. You don't have to expand the bottom out if you don't like to. But the top line, of course, over here had to be expanded and simplified, didn't it? Part C. Investment of 1,000 to double in value to 2,000. Following equation, okay. So a lot of words over here, but we don't fuss about that because we just have a look at if an investment takes 11 years to double in value, what is its rate of return? Think about this. They give you an equation, didn't they? Remember the whole purpose of an equation? It's supposed to perform a certain function. It's supposed to give you useful information. So when they're asking you over here, you recognize this is how you interpret it, right? If you go straight to the question, if it takes you 11 years to double in value, what's the rate of return? It's just like, well, do we have enough awareness to be able to tell that? Are they asking us for the letter R? You spot, oh. Yeah? You following this? Yeah? So if you're looking for the rate of return, it's asking for the letter R. Okay, it's asking for the letter R. We can sort of tell where this is going, isn't it? It's going to some sort of an equation, numbers plugged into a number where there's only one letter remaining that you need to rearrange for. They're telling you D is the amount of time it takes to double in value. Okay. If it takes 11 years, doesn't that just mean D is equal to 11? Do you see what they're really testing you on? They're testing on, hey, do I recognize that if they're telling me 11 years to double in value, it just means D is equal to 11. And I just have to rearrange for R like that. That's how simple it is. So I go ahead and do that. So that's where I get 2,000 is equal to 1,000, bracket 1 plus R over 100 to the power of 11. And that's what this expression is. So, explaining this in real time, okay? If we annotate this, it means when they tell you it's 11 years to double in value, and then what's also representing the amount of time it takes to double in value, it's the letter D. So it just means D is equal to 11, comma, R is equal to question mark. That's what they're really asking for. And they gave you an equation over here to use. You just have to substitute that in and use basic algebra to rearrange for that missing letter, isn't it? And that's where you get 2,000 is equal to 1,000, bracket 1 plus R over 100 to the power of 11, just like that. And then you can tell over here, well, this is just rearranged for R, isn't it? You can tell basics of algebra over here. Step 1, maybe you'd like to move the right-hand side, left-hand side, swap them, so at least you have the letter on the left-hand side, which is where you get this, equals to 2,000, like that. And then you realize, well, you can move this to the other side by division, isn't it? 1,000 multiplied by this, that's what's really shown over here. Whatever you do to the left-hand side, move it to the other side, it's the opposite of what it was before. If it was 1,000 multiplied by, then it means this divided by 1,000. Should know this. That's where they get this first line of working over here. 1 plus R over 100, yeah, equals 2. And then you realize you have to get rid of that to the power of 11, isn't it? You've got to move that 11 to the other side. If something to the power of 11 is equal to 2, doesn't that mean that something inside the bracket must be the 11th root, which is what this is? Any confusions there? And you understand, to the power of 11, or you can also think about it this way. Why is it going to be the 11th root? What's the opposite to the power of 11? It's the 11th root of something. So move that to the other side, it's just 11th root over 2. Which is where you get 1.065. And then the rest is very straightforward because you have a simple algebra expression, 1 plus R over 100 equals to 1.065. What do you want? Rearrange for R. Because if you rearrange for R, you're going to get the answer. You can say R over 100 is equal to 1.065 minus 1. So you get R over 100 equals to 0.065. R is then equal to 100 multiplied to the other side, 0.065 times 100. And that's where you get 6.5. In case that's not clear, I'll write it quickly over here. By the time you get to this step, you ought to know the basic algebra over here is just what? r over 100 equals to this minus 1 over there, which is 0.065, and r is equal to this times 100, which is 6.5, which of course is 6.5%. Part 11, making d the subject of the expression. Making d the subject of the expression. Isn't that just rearrange for d? So we go ahead and do that. If this working over here is confusing to you, don't worry. You at least understand how this divided by 1,000 is the first step, agreed, and that's where you get the power of d is equal to 2, just like that. Next step, if you want to show that d is equal to this, as in you rearranging, make d the subject of the formula, you understand what technique exists so that you can bring something in a power outside of it. Do you see the d over there? It's problematic, isn't it? It's to the power of d. How do you get the d by itself? How do you even pull that out? How do you unfuck it from this to the power of d sort of situation? You know what I'm talking about here, yes? As you can see the issue over here. Assuming you don't know the basics of logs over here, I'm explaining to you. You should sort of see the difficulty over here. Something to the power of d is equal to 2. You need to find a way to get the d by itself. D is right now trapped inside this function of to the power of d. This is where they're testing on the basic of. Do you remember the basics of if you have 2 to the power of x, if you were to do log of this whole thing, you end up saying it's the same thing as x log 2. That's what you have to be aware of. You have to be aware of that. Log times log of 2 to the power of x is the same thing as x multiplied by log 2. Ln of 3 to the power of x equals to x times ln 3. Log of x to the power of 4 equals to 4 log x. Yeah? And then if you have, say, x to the power of 7, you do log of this is equal to 7 log x. So you see the advantage of doing this, because if you have a situation where you have 1 plus r over 100, tell me if this helps. You want to get the d by itself. You want to sort of even at least bring it down from above to level. Yeah. What happens if you do log of that? See what happened over here? If you have, say, 2 to the power of d over here, and you did log of that, what happens? You're allowed to, you're allowed to say it's going to be the same thing as d times log 2. And do you see the advantage of this? This relationship over here, which you know is true now, okay, for logs, the basics of logs, it allows you to do what? What happens when you basically, if you start off as 2 to the power of d and you log it, what happens when you log something? When you log something, you take something that's originally in the power and you bring it down, didn't you? See how afterwards it's brought down? It's no longer in that function. It's a very simple scenario now, whereas it was d multiplied by this. Yeah? So you recognize if you have the scenario where it's 1 plus r over 100 to the power of d equals to 2. If you do log of both sides, what happens now? Log of this equals to log of this. Of course, this is the basic rule of whatever you do to the left, you must do to the right. Log of this whole thing, isn't it just, well, log of x to the power of d is equal to d times log x. So isn't this the same thing as d multiplied by log of this and equal to log 2? See what they did over here? That's what this third line of working is. D multiplied, because you can move the d outside. And this is just the same thing as d multiplied by this equals to log 2. So the answer is just d is equal to, you just do the right hand side divided by whatever is interfering with the d being by itself now, isn't it? Which is what this final line of working is. Remember this question, you don't move on from it just by watching this tutorial, okay? If you're watching this, you make sure you only move on when you go back to the beginning, blank paper, write the whole thing beginning to end without looking at the solution. Unassisted, that's the only way you move on. That's the only way you're going to really learn when to do logs. So key takeaway over here is, best way to tell if you need to do logs a lot of times is if you need to bring some sort of power back down. If you need to isolate it. This question is really asking you to isolate the d. You can't isolate that if it's hovering above in a power, isn't it? Doing log of that will remove it from that power. That's the key point over there. I don't even want to read that. Okay, you just go straight to part 3. They want you to show that the value of r, like you read the question first and then you go back, just in case you end up having to read a lot of stuff that didn't relate to solving the question. Okay? So what I'm saying is you go straight to the question, straight to the instruction. They want you to show, so finding something, the value of r for which this exactly calculates d, is the solution to this. This is where you realize, okay? How do you prove something is the solution to something? Listen very carefully. In order to prove something is a solution to the equation, you're proving that it satisfies it. As in, the value of r for which rule of 72 calculates d, they're talking about the value of r for a certain scenario. So R is going to be equal to something for a certain scenario. You're trying to prove that the R that satisfies rule of 72, whatever that is going to satisfy this. That's what they mean. You have to understand solution is really just, by basic definition, no matter what your equation is. This is a strange looking equation, you agree. It's of course a strange looking equation. But the solution to this equation over here, it still means what? It doesn't change what the definition of a solution is. A solution is just a number that will satisfy that missing letter over there. There's a missing letter over there for R. The solution is just whatever number replaced that missing letter over there. That's all it is at the end of the day. So if you want to show that the value of R for this is the solution to this, can you see my cursor? You can see the little hand moving. Can you see my cursor moving? Yeah? I'm saying, do you realize the solution to this equation over here is really just asking you to find what the R is over here and prove that the R over there satisfies the R over here. The R that satisfies the rule of 72, whatever that is the R that's going to satisfy the R in here. That's what they mean by a solution to the equation. So without further ado, we go find what the R is for the rule of 72. Now we go back. Let's have a look at what the rule of 72 is. So the rule of 72 is time that the investment takes to double in value. Okay. D is equal to 72 over R. Okay. So they're saying the rule of 72 that exactly calculates D. She's saying the rule of 72 that she's thinking about is D is equal to 72 over R. So that's her idea of what can work. This one over here, they're asking you, they're telling you, this is the actual expression, as in the thing that actually solves whatever. So the rule of 72 over here is really just asking you to find what number D has to be to get double the investment, yeah? Like first, I'm saying, do you understand what this expression really represents? D is equal to 72 over R is her approximate number, so it's not actually the exact answer. This is what the exact answer is the point. Okay, so you realize this is the exact answer. So saying, for the answer that exactly calculates D, they're basically saying for this equation over here. So that's good? For the answer that exactly calculates over here is the solution to this equation. That's what they're talking about. Are you following so far? Yeah. So she has two expressions for the rule of 72. She's got her expression over there and the expression over there. And they want you to prove basically how her solution and the actual solution eventually leads to what? Something that solves this. Is that clear? So how do you write the equation that represents? So you know you have to start off with some sort of equation, something equaling something. If you have D is equal to this and D is equal to this, you don't need to be told why this is equal to this. Is how you start now, isn't it? Would that not be the most common sense thing you could look at? Yeah, so you go and do that. And that's what this first line of working really is. That's all it is. Once you have this, you realize you need to prove how it eventually becomes this. How do you prove it eventually becomes this? Well, you can prove it by, first off, look at what you have in the first line and look at what you want it to become. That thing doesn't have fractions of it really, does it? It's not a fraction equaling a fraction. So what's the first thing you can do to make this non-fraction? You can cross multiply. So that's why you cross multiply. 72 multiplied by this, and then R multiplied by log 2. In the next step, you realize, remember, look over here, do they have R really anywhere by itself? No. R is always inside a bracket or inside a function. So this is where you realize R log 2 is the same thing as what? Log of 2 to the power of R. So you go ahead and do that, log of 2 to the power of R. Agreed? In the left hand side over here, same thing. You don't have, do they even have the letter, like the word log? No, they don't. So which is what? It's the same thing as, if you did it on the right hand side, if you did R to the power over there, you can tell that 72 log this is the same thing as this originally. What would have been originally if you put the 72 not on the outside? It would have been to the power of 72 on the inside, isn't it? Hope that explains how you get to the third line of working. And if you have log of this thing is equal to log of another, the logs over here mean the same thing, don't they? Log of this equaling log of this must mean the insides better be the same, because otherwise it wouldn't be equal. And now you have this expression. It's very, once you get to this expression, testing you, do you have the awareness to be able to tell it, hey, this already looks really similar to this, isn't it? The only difference is what? You just move this to the other side, minus equaling 0, so you just minus that equals to 0. And that's how you proved it is a solution to that. Because the best way to prove if it's a solution, the solution for this, as in the R value that satisfies this, is going to be a solution to this, is, well, you prove that this equation can become this equation. Because think about it, if two things that started off different end up being the same equation, of course they're going to have the same solution, isn't it? That's the basic you have to understand here. It's just tested in a very long-winded way. This one, don't worry about all these words over here, just look straight over here. Using algebra, find the volume of this cuboid. The volume of this cuboid, isn't it just going to be... Come on, what's the volume of a cuboid formula? All three sides multiply together, so you go ahead and all three sides multiply together. P over 2 times 2 over P times P. Done. P to the power of 3. Easy. Volume of the cuboid, P minus 4 times P plus 5 times P minus 3. If you multiply and expand these together, what do you get? In case you're confused about how you do this, easiest way to do this is you can expand two of them first. Do you remember the commutative law of multiplication? This is just basics over here. Do you remember the basics of, just in case you don't know this, do you agree that 2 times 3 times 7 is the same thing as 3 times 7 first times 2? As in the same thing as 2 times 21. Remember that law of multiplication? As in multiplication, if the whole thing is multiplied together, it doesn't matter which order in which you do them. So you realize it's the same thing as doing this first, can't you? It's the same thing as P minus 4 multiplied by. You should be able to do this off the top of your head, but if you can't, you can still write it the long way. P times P minus 3 plus 5 times this. But this is where you get overall P squared plus 2P minus 15. And you know by definition, two brackets multiply together. Of course, the first thing times the second bracket, the second thing times the second brackets. P to the power of 3 plus 2P squared plus 5P. You know how this goes. Minus 4 times this, minus 4P squared. Minus 4 times this, minus 8P. Minus 4 times this, minus 20. You see how that's going, right? All of this, P cubed minus 2P squared minus 3P minus 20, just like that. Dot, 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 dot. Yeah? That's what they've really done over here. It was P multiplied by second thing, minus 4 multiplied by the second thing. Expanded out, grouped together like terms, and then eventually you get P cubed minus whatever that is. Very straightforward. Doubt that's an excellent question. Part C. Junior. Yep, diversity. Fuck with Koreans, okay? Diversity quota, yep. Okay, so Junyang. Go straight to the question. I'm explaining to you in real time like how you want to just approach these questions, yeah? Like the thought process is really, just go straight to the question. Go back if you have to. But they're asking any values of A, okay. The same as the volume of the cube. So, volume of the cuboid, same as the volume of the cube. Well, you think to yourself, well, I know there's got to be some sort of letters and numbers, some equation that represents the volume of the cuboid, isn't it? Remember the previous part of the question? The volume of the cuboid is... It's just three sides fucking multiplied together, and you've got this cuboid. It's literally written in front of you. It's like right there. You don't need to be told the volume of the cuboid is represented by what? P times this times this. P minus A, multiplied by P plus A, multiplied by P. So you go ahead and do that, and that's what they've really done over here. And of course, you don't need to be told to simplify that. And they're saying for which to be the same as the volume of the cube. Okay, volume of the cube. Well, go ahead and find something that represents the volume of the cube then, isn't it? So the volume of the cube is just going to be, isn't it just P to the power of 3? Do you get it? Because the volume of the cube is just P to the power of 3. I mean, fucking... Look at this. Yeah? They tell you the volume of the cuboid, like volume of a cube, in the actual exam, remember they tell you the volume of the cube is going to be P cubed at the start of the question. So I'm just explaining to you, that's how you get the volume of the cuboid and get the volume of the cube. And then my point is this, okay, any values of A for which the volume of the cuboid will be the same as the volume of the cube. Remember the common sense question? In case you don't understand what this is asking, you should understand this straight away and know what to do. But in case you don't, let me give you a basic thought experiment over here. If someone told you, are there any excuses you can give to the biggest cunt teacher in your school about being late to class? Think about that. Think about the worst fucking cunt in your whole school. He would always just shit on you if you're late to class, no matter what reason you give to him. Even if you told him you're saving his mother and he wouldn't accept that excuse. Just everyone's got one of those teachers in school. Agreed? So if someone asks you, are there any reasons you can give to him? Are there any excuses you could give to him? What does that really involve doing? It involves finding out if there's any actual reasons. Agreed? So you probably go investigate. You probably try every single possible excuse or reason or some sort of approach to it that involves finding if there are any actual reasons. So you probably try a lot of different reasons. And then until you exhausted every possible reason you feel like can work or could work, and then you determine whether or not there are any excuses you can give to him that would work. I'm sure you get the point here. So if you look at how that applies to this question, so really basic scenario as before, see how that applies to this question? Are they saying any values A for which the volume of the cuboid will be the same as the volume of the cube? It just means find out if you can solve, is A equal to any particular number? Do you agree that the volume of the cuboid is represented using the letter A? Is the letter A used to represent the volume of the cuboid? Yes. It's P cubed minus PA squared. Okay? If they're asking you any values of A for which they can be the same, it just means, well, what try find if there's anything that can make it same. And how would you find the value of A that makes the cuboid and the cube the same? It just means making the volume equations equal to each other, isn't it? Is that not the most logical thing to do? Because that's how you would solve for the value of A that makes them both equal. And that's what you're really doing over here. You're taking the volume of the cuboid, making it equal to the volume of the cube. Remember, the volume of the cube is p cubed. And when you do this, you realize what? Doing basic algebra to solve for it, remember you're trying to rearrange for A? Because you're trying to find if there's any value of A that makes this true. Because this is the equation that makes it true, doesn't it? This is the equation that represents, oh, cuboid and cube is the same. Now you rearrange for A. How do you rearrange for A? Well, if you move p cubed to the other side, you move to the other side, you get pa squared equals to 0, yes or no? You can always think about it this way, okay? If you, some of you might do the algebra this way. It'll be minus pa squared equals to p cubed minus p cubed to get 0. If you end up with this scenario, it doesn't matter because it still ends up what? A squared is equal to, because you divide that to the side is 0. You rearrange for this. The point is, A is equal to 0 is the only answer. And now, so does that prove, are there any values of A? Of course. A is equal to 0. It makes it true, doesn't it? Just go straight to the fucking question, yeah. Ugh. Surface area of the cube, same as surface of the cuboid. Show that this. How do you show an equation? You show something that starts off to represent something in equation form that represents the relationship they give to you, isn't it? So the relationship they're talking about is surface area of the cube is same as surface area of the cuboid. Do you have something that represents the surface area of the cube? Do you have something that represents the surface area of the cube? Of course you do. Of course you do. Remember what the cube is? The cube was what? So do you understand what we're doing over here? As in, you can only do this question over here with what? You know how to start it off. And the way you start it off is, there must be some sort of equation you can write down that represents this relationship that you rearranged to make it become whatever this is. Whatever they're saying you must show. In fact, they even tell you what the surface area of the cube is, isn't it? So you just make this equal to what? Whatever represents this surface area over here for this cuboid. And isn't that just... I mean, even if you didn't know how to do the math over here, you'd understand the surface area of a cuboid. The surface area of any shape is just every single two-dimensional space, every single two-dimensional component added up together that makes up the three-dimensional shape. You know, p minus a multiplied by 10, isn't that going to give you the area of this first face? Yes or no? And you have two of those, so you multiply that by 2. Just like p plus a times 10, you multiply that by 2, because you've got 2 of those. And the last one is what? The top and bottom, which is, top is p plus a multiplied by p minus a, and you've got 2 of those, so you multiply that by 2. So that's what they've abbreviated over here. It just means, do you agree that every single one of these faces you see over here is multiplied by 2? Of course. So that's why you do 2 overall multiplied by p minus a times 10, p plus a times 10, plus 10 times p plus a. Okay? Like this. You don't need to be told that the brackets inside of there, because remember, there's a lot of ways you can approach this question. I'm explaining to you the work masking method because this is the quickest way, right? The quickest way is, you can tell that everything inside can be individually expanded and simplified first, so you go ahead and do that. P minus a times p plus a, of course, p squared minus a squared, 10p minus 10a, 10p plus 10a. See how the 10p's become 20p, and the minus 10a plus 10a cancels out. That's where they get this expression, and you multiply that by 2. That's where you get that. That's the surface area of the cuboid. The surface area of the cuboid is expanded and simplified into this expression over here, 2p squared minus 2a squared plus 40p. And they're telling you it's equal to the surface area of the cuboid. Excuse me, they're telling you the surface area of the cube is the same, right? So you make it equal to the surface area of the cube, which is 6p squared. And then the rest is just basic algebra, yes or no? Basic quadratics. Move the p squared to the other side. A lot of ways you can go about doing this. Even if you decided to move it this way, okay? You get negative 4p squared minus 2a squared plus 40p. How do you show it becomes this? Isn't that just, well, see everything over here is exactly 2 times smaller? You could probably just divide the whole thing by 2, couldn't you? Negative 2p squared minus a squared plus 20p equals to 0. What's missing over here to make it look like this? Oh, they multiplied by negative 1 both sides, yes or no? 2p squared plus a squared minus 20p equals 0. Almost looks like it, doesn't it? Oh, it just means move the a squared to there and move that to there, isn't it? Yeah, a lot of ways to go about it. I'm sure this will be intuitive to you. I'm sure you should be able to comprehend this. This thing over here, part 2, surface area of the cube is the same as the surface area of the cuboids. Surface area of the cube is the same as, okay, alright. Yeah, so the equation is before, okay. Yep. Discriminants, this is where you remember the basics over here. You need to know the basics of what the discriminant relationships are. Remember the triangle, if it's negative, it is 0 solutions. If it's positive, 2 solutions. If it's equal to 0, 1 solution. So they're asking the largest whole number that A could take in this context. Context being what? Convex being what? They're telling you the surface area and is the same as surface area for both of them. For the two shapes, you've got a cube and a cuboid, is this equation. So when you solve this, you're going to find what you're finding what P is equal to, right, to make this true. Agreed? As in, that's what the definition of this is. As in, the whole purpose of this equation is, it's allowing you to find what P must be equal to make the surface area of the cube the same as the surface area of the cuboid. Okay, that's a certain scenario. That scenario only happens when P is equal to a certain number. Okay, just make sure you're aware of that, what that even is, yeah? And if you're talking about the discriminant over here, they're asking you to use the discriminant to find the largest whole number that A could take in this context. What they're really saying is, do you agree that this equation over here, if there turned out to be no value for P, as in there wasn't any number you could replace P with over here to make it equal to 0, isn't that the same thing as saying the surface area of the cube will never be the same as the surface of the cuboids? You have to make that link. You have to understand this is the equation that allows you to solve what P is equal to in order for the surface area of the cube to be the same as the surface area of the cuboids. If it turns out that this doesn't have an answer, as in this, because that can happen. I mean, who says if you write an equation that has to be an answer to make it true? Who said that has to be true? Yeah? Right? As in, I mean, just think about the basic concept over here. This is quite important, right? Let's just say hypothetically, if H is a letter that represents your fighting ability in numbers on any given day. So of course, like, depending on how you slept or all that kind of stuff, depending on any given day, your fighting ability can change. Agreed? It's not always just a constant number now, is it? Everyone's number changes depending on what time of day or whatever that's happening with that person. Agreed? Let's just say this represents another kid. Maybe his name's Danu. Okay, it's a number that D is the number that represents this guy's combative ability on any given day. Hard to tell. If it turns out that no matter what, your combative ability at its very highest is like 10,000, and this guy's highest one at very best is like 9,100, can you solve the equation for H plus D equals to 1,000,000? Does that, do you understand? Do you need any explanation as to why, no matter what, there's not going to be a number that H can be over here or D can be over here to make this equal to 1,000,000? If you know for a fact H at maximum is of 10,000 and D at maximum is 9,100. Do you fathom this concept here, okay? So not all equations can be solved. That's the point. My point is over here, you realize this is the equation that you would solve. You'd find the P value to make the surface area of the cube the same as the surface area of the cuboid. But who said P has to equal a number? Who said it has to? No one said it had to, right? And you understand the scenario in which it doesn't have an answer is where what? The triangle would have been negative. I'm assuming you understand the basic of discriminants over here. If you're not, go check the links in the document, in the exam document. They'll be there for the basics of discriminants. This is assuming you know the basic of discriminants over here, how the triangle works. The triangle, remember, is just how you are able to tell if it has any answers or not, if it has any solutions. Does this have any solutions over here? Are they asking you for the scenario where it has any solutions or doesn't have any solutions? They're asking you for what? Largest possible value you can take. Do you understand they're asking you for what's the biggest value? So what is the biggest possible value A can be so that this does have a solution, which means what? Discriminant is positive. They want the scenario where it actually does have an answer. So you go ahead and what left to do other than to find the fucking triangle? And you know the triangle, the discriminant is just what? B squared minus 4AC. So you go ahead and find B squared minus 4AC. You write down A is equal to, what's A? 2. What's B? Negative 20. And then C is A squared. So you go ahead and write down B squared minus 4AC. What's B squared minus 4AC? It's going to be negative 20 squared, which is 400, minus 4 times 2 times A squared, which is minus 8A squared. That's where they get this expression from. And that's where you get that bigger than 0, because that's the relationship that describes what? This is going to have a solution. Yeah? And then once you've got to this step, I mean, come on, that's very self-explanatory. You know what you need to do. You need to find what A is. Rearrange for the A. So you get 50 is greater than A squared. And this is where you got to be really careful over here, okay? You understand that A squared is what? If you get 50 is bigger than A squared, this is where you have to be able to adjust this. You have to understand that. So we've got to this step now, okay? They're asking you what the biggest possible value of A is. This is where you realize it's the same thing as what? A squared is less than 50, agreed? No difficulty over there, making that link. And then you know it's going to be between 50 and square root of 50. Excuse me, square root of 50 and negative square root of 50. Because A squared to the other side is square roots, right? But remember, square root has plus or minus. This is just a general rule you need to write down. You didn't know about this rule. As in, if you have anything squared less than a number, the inequality that satisfies it is this. I think a lot of you watching this probably are not familiar with this basic, so I'm going to explain this basic to you, okay? This is just the core principle you need to know about. It comes up a lot. As in, do you understand? If you have x less than 7, what's that really representing? It's just any number for x as long as it's less than 7. So x equals to 8, it's not true. X equals 6, it's true. You get the whole point of what x less than 7 is. You get what this inequality is really showing you. It's just showing you this missing number x. As long as it's less than 7, it's valid. It's okay. If you have x between -7 and 10 over here, if x just so happened to be something that represented the dimensions of, if you have a 10 by x, so you have like a 10 meter long pool, and you're choosing how long you want the width to be, which is what x is. Do you understand? If x has to be between this and this, technically it's not between -7 and 10, is it? It's up to you to be able to tell. It's actually between what, 0 and 10. See how that works? Because x is a literal fucking dimension. You can't have a negative dimension, can you? If you're saying it's between -7 and 10, you're including negative possible answers for x. You need to be able to adapt that. You'll see how this is relevant for this question we're doing over here for the exam scenario. You'll see that later. I'm just explaining to you, you better know what this principle is. Okay, this basic over here. Have that in mind. This building blocks for you to be able to understand these questions. If you have, now, x squared less than 4, the reason why, so this is just a rule, you memorize this from now on. It's just really plus or minus square roots, of course, but they're written in this format. And I'll tell you why, because check it out. Take any number between -2 and 2 and substitute into here, see if it's true or not. Any number between -2 and 2. Let's say hypothetically 1. Do you agree that 1 is an example of a number between -2 and 2, according to this instruction? What happens if you substitute 1 into here? X squared becomes 1. Is 1 indeed less than 4? Of course it is. Choose any number between here and here again. 0. Yeah, 0 is between -2 and 2. 0 squared, is that less than 4? Of course, because 0 is less than 4. Take any number between 1.5. Let's just say 1.5, yeah. Is 1.5 between -2 and 2? Yes or no? You tell me. No shit. 1.5, of course, it's between -2 and 2. So we substitute into x squared now, right? And we get 1.5. You can tell 1.5 squared. It's going to be less than 4. It's valid. Now take any example of a number that's not in this region over here. 4. 4 squared, is that going to be less than 4? No, of course not. It's 16. You see what I mean? So do you see that's how it's true. I'm showing you how that's true, okay? So from now on, if you see any fucking letter to the power of 2 less than a number, it's just going to be the answer is. You see what we really did over there? Like, why does this help? Because this is literally telling you what number you're allowed to put over here so that when you square it, it does indeed become less than 4. I mean, how's that not solving a problem, yeah? See the point? Like, you see why we care? Now, if we have x squared is less than 10, yeah? X must be between negative square root of 10 and then square root of 10 like that, yes? If you have x squared less than 100, what do you think that's going to be? Okay? So you memorize this rule from now on. Very good. So now we go back to this question. Remember the question from before? We got up to 50 is greater than a squared. A squared is less than 50. And that explains why a is between 50 square roots and negative 50 square roots. Type in negative 50 on your calculator. Type that in. It's like 7.07, isn't it? So it's technically negative 7.07 recurring. And then 707 recurring. Now, remember what a is? Remember a is a certain dimension over here? A is a fucking dimension over here, isn't it? It's an actual length. Do you understand for this question over here, we can't actually have what? We can't have a fucking negative dimension, can we? Simple point? Yeah? So that's why, for this question over here, it's not actually between -7 and 7.07. It's actually between 0 and that. See how they changed it to between 0 and... Because I mean 7.07 recurring is rounds off to 7.1, isn't it? Are you confused about how? Just make sure you understand. Make sure you understand how negative 7.07 between this gets changed into 0 and 7.1 like that. Okay, because a is an actual dimension over there. Now if a is equal to 7, do you see like uses value of a to find the dimensions? They're saying find the largest possible value of a that can take. So if they're telling you a has to be between 0 and 7.1, remember a has to be a whole number? What's the biggest whole number between 0 and 7.1? They're telling you a has to be between 0 and 7.1. Of course it's 7, right? So you say a is equal to 7, and then you plug that into this equation over here. And that's what we get. We get 20, so 2 times p squared minus 20 times p. Don't worry about this working out. Some of it's actually quite confusing. You should understand up to now that we got a is equal to 7, no problem. So we substitute that back in now, isn't it? Because if we substitute the a over here for 7, we get an actual equation that can be solved. Before, if we just leave a as a, that's not going to be solvable, is it now? We're not going to get p is equal to an actual number. But now if you get a is equal to 7, you get an actual equation over here. And then when you go ahead and solve that, of course you will get p is equal to 5.07707 or 4.293. I'm assuming you know how to solve the quadratic over here, no problem. But you remember, they ask you to find the dimensions of the cube and the cuboids. These two look like they could both be allowed for the cube and the cube, doesn't it? The cube is just p. There's only one dimension. P is over equal to this or this. There's no problem. Like, you can have a cube of this dimension or cube of this dimension for each of the sides. But for the cuboid over here, they're asking you, do you see how they're asking you this question in a way where it implies it can only be one of these answers? It can't be two possible p-values, can it? Do you agree? Like, they're asking in a way where dimensions are both. It's like, it's not possible dimensions. If there's more than one possible sort of set of numbers, they'd say possible dimensions. Over here, they're asking you, it's really clear they're asking you in a way there's only one set of answers, isn't it? So you have to tell, how do I know it's going to be 5, or how do I know it's going to be 4 point something? Look at the actual diagram. P minus A, P plus A. If A is equal to 7 over here, and P is equal to this, what happens if you did P minus A? Isn't that going to be the dimension of this, P minus A? 5.707 minus 7, you don't even be told it's going to be negative. That's not valid, is it? And that's why we only choose this answer over here. Rewind the video, press J if you didn't understand that part. Press J and then pause if you have to, if you didn't understand that part. But you should understand that P cannot equal to 5.707 because this, what? Minus 7. This minus 7 is going to be negative, isn't it? But if you did this minus 7, what happens? It'd also be fucking negative, isn't it? No, neither of those are valid. So we think back now. Well, we know A has to be between 0 and 7.1. This is where you realize, oh shit, I can't actually equal to 7. Do you agree? Do you see why we go down now? Yeah, so we get 6. And if you solve that now, instead of 49, it becomes 36 now, doesn't it? Yeah, and when you go ahead and solve that, you end up getting P is equal to 7.646. Or P is equal to 2.5354, and you realize this minus A, so this minus 6, is that going to be a positive number? Yes. This minus 6 is negative. That's how you know this is the answer. So the answer is P is equal to 7.646, A is equal to 6. So dimensions are what? Remember that question's asking you what to find the dimensions? Dimensions, you're going to give actual numbers. A cube has what? Only one dimension. So the cube is, you say the cube has sides of 7.646 centimeters, and then you say the cuboid has sides of this minus 6, which is 1.646 by what? You know how to represent the dimensions of a cuboid. It's number times number times number, right? Next one is P plus A, so you just do this plus this, which is 13.646. And the last one is 10. So